Hello everyone. Welcome to TeachCard Tutorials. The topic for today's tutorial is analysis for temperature change due to friction on a body using Ansys Workbench and user-defined functions. The contents of this tutorial include two main topics. Firstly, it is about basic import of a model. Secondly, we would like to include user-defined functions for degree of freedoms of temp in transient structural analysis, considering the fact that structural analysis doesn't contain this function. If you want more references on the element type, you can visit this website here. For applying frictional contacts, extra degree of freedoms, and real constants, you should visit this website here. To know more about the commands, you can go to Ansys Workbench Help and then go to Commands. To import a model, you can go to teachcard.com to view more tutorials. Now, we will open transient structural analysis in Ansys Workbench. The next step is to import 3D geometry here. For this, right-click on the Geometry tab. Go to Import Geometry and click Browse to select the geometry. Now, right-click on Model and click on Edit. Now, we are in the Mechanical Modeler. Expand the Geometry tab to view all the parts underneath. Now, we will rename the part according to our preferences. For rename, right-click on the part option and choose Rename. Now, we will use user-defined functions to include the DOF of temp and the element type. For that, right-click on any part, go to Insert, and select Commands. Now, you can enter these commands as visible on the command window. To know more about the commands used previously, you can go to the Ansys Commands Manual. In that command, 226 is element type, and the number 11 is enabling extra degree of freedoms of temperature. Drag and drop that command option to the other part. Now, we will define the contacts which can be found under the Connections option. Now, we will rename the contact region according to its definition. For that, right-click on the contact region and select the option Rename based on definition. Now, we will enter the details for the contact region. For that, in the Type option of the Definition tab, choose the option called Frictional. We will change the value of the frictional coefficient to 0.3. In the Behavior tab, change it to asymmetric. The reason we chose asymmetric behavior is that it defines all contact elements on one surface and the target elements on the other surface, unlike symmetric behavior, where each surface is considered target and contact element. Now, we will change formulation in Advanced tab to Augmented Lagrange. The reason for choosing Augmented Lagrange is because of their property. They have a property of being able to solve constraint optimization problems. Now, in the same tab, we change Update Stiffness to each iteration. We changed it to each iteration option because it aids in the convergence of solution. Now click on Connections tab and change the auto detection option to No. We chose the No option because after this, Ansys cannot change the definition of the contacts defined. Now we will use UDF to define real constant of frictional contact. For that, we right-click on this option and go to Insert and choose Commands. Now you can enter these commands as visible in the command window. In this UDF, the first line enables temp as a DOF for structural analysis. The second line defines the value of the 15th real constant, which is FHTG, and specifies the fraction of frictional dissipated energy converted into heat. The third line defines the value of the 18th real constant, which is FWGT, and specifies the weight factor for the distribution of heat between the contact and target surfaces for thermal contact. The basic heat dissipation equation for friction in Ansys is as follows. The rate of frictional dissipation is given by this formula, where τ equals to the equivalent frictional stress and V stands for the sliding rate. The amount of frictional dissipation on contact and target surfaces is defined by this equation. Now we will mesh our geometry. For that, right-click on the Mesh option and go to Insert and choose Sizing. Now, in Geometry Selection, select the whole body and click Apply. After that, we will insert Element Size. We will input the value of the element size as 5 mm. This is done to reduce the computational time. Now we will go to Analysis Settings. There, we change the number of steps to 10. Change Auto Time Stepping mode to On and change the Define By option to Time. Now we will define initial minimum and maximum time steps as follows. Now, in the graph bar on the right, select all the 10 stub-steps by pressing the Shift key. Then we insert initial minimum and maximum time steps. You can ignore the previous of time steps because the latter definition takes care of all the sub-steps, as you can see here. Now, in the nonlinear control option, we will define the method for our solution. For that, change the stabilization to constant value and insert the value of the energy dissipation ratio to 0.1. Now, we will use UDF to define thermal boundary conditions. For that, right-click on Transient, go to Insert, and choose Commands. Now, you can enter these commands as visible on the command window. To know more about these commands, you can refer to the Ansys workbench. The first line defines the reference temperature. The second line selects nodes on faces named as temp, which we will define later. The third line assigns initial value to the nodes, and the fourth line selects all the entities on the face for solving. Now we will define the face named as temp. For that, go to View tab, then go to the toolbar option and click on Named Selections. Now click on Model option and select the face. Then click on this icon as shown above. Then you can write temp there and click OK. And then you can see a new option formed here. Now we will define connections. For that, click on the Connections tab. In the Body Ground option, select Fixed. Now select the bottom surface of the slab and double-click on the Scope option.